let's say if this is a trim, so for trim the buffer holes, you have to reduce the spacing for the buffer holes. Okay, so if this one was to be a trim pattern, you have to um so this one here will be our wall. Okay, so here the label will change. So here will be our wall. Because the trim patterns are the patterns that are close to the wall. So we take them, the patterns that are close to the wall. Okay. So here will be your wall like this. So for the trim pattern, the spacing, and the bedding differ. Okay. You have to reduce the pattern size for the buffer holes. That's for the trim, for trim patterns. That's what we do. So that and we also charge it lightly. We don't use the explosive we use to charge. We don't use the same quantity of explosive that we use to charge production holes to charge the buffer hole. No, we reduce the amount of explosives so that we won't get more of the energy going to the wall or impacting on the wall. Okay, we want a lesser energy at the wall, so that's why we reduce the pattern at where the buffer hole, the hole that is closer to the wall. So if this one is to be a trim, you have to delete these holes here. Okay, you have to delete these holes here like this. Then you use this property, the row tool. You left click on it. If you left click on it, this will pop up. Then you set the pattern for the trim. So for trim, I said you have to reduce the spacing. So let's make it like 3 meters. Okay. The offset, after the offset, is not that necessary because already we want it to appear on this same row. But better still, you can still set your offset. So let's make the offset to 3 meters. And for the whole ID, you can decide to name it whatever way you want. So BH, or let's make it BHT. BHT, that means glass hole trim. Okay. Then okay. So you can now choose where you want the holes to appear. So left click, left click again. So the holes will appear there. So have you seen it? There's a hole here, no, we delete it. Okay. So that's the trim. So this will be the buffer holes. Buffer holes. Okay. Let's position it. Then you can use this arrow to point it like this. Right. Are you okay with that? Are you okay? Okay, so this is how you design a pattern. Okay, so at your own convenient time, you can do more, and you can't do everything here. Okay, so you can be using, and this one, you can use this one. If you want to add a hole somewhere, so use this to add hole. You just left click on it. This one will pop up. So um, you depending on the other hole that you have, the bit diameter. If the other hole that you have, the bit diameter, you see here is 127. So if you click on OK, the whole diameter for that particular hole you add will be 127, but you want 165, so you just click on the change. If you click on the change, this will pop up. Then, okay, see, it has changed 165, then you can click on OK. Then you can just click on wherever you want the hole to appear. Let's say you want a hole to appear here. Okay, just click there to appear. So you can add hole to wherever you want. Okay, yeah. So that's it. That's how you design a pattern. So look at the tie-up. The tie-up, for the tie-up, we will look at three types of tie-ups. Okay, we will look at and the criteria that I'm using. Please hope we are okay with this one, so I can close it. We are moving on to the tie-up.
Yes, sir.
Yes, sir, but please, I want to ask a question.
Okay.
So this software helps you to design a blast, let's say on paper, before you execute it on ground, and it
Yes.
helps you to know the outcome. So assuming as a blast engineer, you have been given a contract, okay, to blast it's a surface mine, obviously. So there's a free phase and all that already. So pre-blasting has already been done.
Okay.
Are you going to take the measurement of the place and bring it exactly onto the software? Then
So,
you continue from there.
okay. So here there are two things that you can do. First, you can do what you are saying. You can let survey go and pick the perimeter that you want. Okay. Then you use that to design your pattern. Or you can import the DTM, data terrain model, the DTM of the pit. He's the one who asked the question. I hope you know it here. DTM.
Yes, sir.
You know DTM, right? Okay, so you can import the DTM of your pit. So you wherever you are working, you can ask them you want the DTM. The DTM is the digital terrain model. So it's the model of your pit. So you can import it here. Import. Okay. So first you have to come if you are using SEPAC in that particular mine, you have to convert the DTM to DSF file. Or if you are using MineSite, you have to convert it to DSF. So if you convert it, you can then import it here as DSF file. Okay, so if you import the DTM here, you will then know, you can zoom in and know the bench, that bench that you want. Everything is there already. So you will just have to digitize and create the polygon at where you want it to appear. Do you get me? Then after that, you can then send this polygon to survey to stick it out in the pit. Are you okay?
Yeah, I'm following.
Yes, so that's how you can go about it. So you have to import your DTM. Then you can then on the DTM, if you have the DTM on it like this, you zoom into the bench that you want to blast. So that particular portion, then you can then digitize the shape that you want. Then you design your holes and everything. You can then, after that, you send the shape to the survey for survey to stick it out on the pit. Then if you're in that mine, they do manual mark out. You have to send the pattern also to survey for survey to stick them out on the pit so that the drillers can drill it. Okay. So that's how you go about it. So first you can let survey go and pick the perimeter. So this is the perimeter. The shape is the perimeter you want them to draw. Then they will send you the coordinate. So if you import the coordinate, you import it just like how we import the data. So you import it as far. So after importing, you get the shape. If you don't get the shape, you get the point. So you can then use this one to join the point. Okay. You join them here, then you
Okay.
design your pattern. You see, yes. So that's how you go about it. Or you can use the import the DTM, then design it on it.
Okay.
Right. So let's look at the tie-up. So tie-up, we'll just look at it. Tie-up, yes, for the tie-up, I was talking about it. For the tie-up, let me change this screen before. So um, yesterday, I wanted us to look at this one, but I was having issues, but I've fixed it. So you look at this. So tie-up, we look at three types of tie-up. And the criteria that I'm using to choose the three is the three phases. Okay. So first, you look at when you have a bench with no free face. No free face. I hope you know you can have a bench with no free face. You know that.
Yeah.
You
Yes.
assuming on that bench, the first blast you are taking. So that means you don't have any free face. So if
Mm.
you don't have any free face, then you look at when you have one free face, then you look at when you have
Multiple
multiple free face.
frequencies.
Yes, multiple. Okay, so this one is a typical example of. So how many free face do you think we have here for this one? This
Multiple
no. This one you can consider it as just one free face.
as one. Yeah,
Yes,
as one.
because it is here. But for two free faces and those stuffs, that's when you have one edge
Different
as a free face
sides.
and you have another edge like here as
Yeah.
another free face. Okay, so
Okay.
this one consider this as one, even though the shape differs, but it's just one free face.
Yeah.
So you deal with when you have one free face, then tomorrow God willing, you will deal with when you have two or more free faces, or when you have no free face or two or more faces. Okay. Because I yesterday I started with this one. That's why I should have started with no free face, then we move on to one free face, then finally multiple free face. But yesterday I started with this one, so I want to finish it. So this one, you have one free face. So for when you have one free face, you use what we call the V type, the V type, V type. Okay. And some people even call it Christmas tree, Christmas tree, because after you are done with the tire, you realize that the shape is like a Christmas tree. Okay, so let's do it. So if you have something like this for a V tire, um, I said first you can have no free face. You take this one seriously. You can have no free face. You can have one free face, then you can have multiple free faces. Okay. So when you have no free face, you use the V tire, the V. Let me write it again. So no free face. You use the
Hmm.
V. Okay. Then when we have one free face, one free
Mm.
face.
That's not easy.
Oh, sorry. No free face. Use the this one free face. No free face. Use the center lifting. Center lift. Center lift. You use it God willing tomorrow. Today we'll just deal with the one free face. Then when you have, let me add the thing. When you have one free face,
V.
you use the V tire. When you have multiple, multiple free faces, you use what? The normal echelon. We can just call it H1. Okay. So this is what we use. So you can write them somewhere. Okay. So with this one is, let me put it here. This one is one free phase. So one free phase, you are coming to use the V. So
Data.
for V, first, every blast, you have to set your initiation point. Initiation point is where the blast will start from. Okay. So with the first hole that will go, you set your initiation point. So the initiation point, we give it zero delay. There is no delay. So because that's the first hole. So for this particular type of blast, you can either put for the V, we set the initiation point at the middle, you see the middle portion, okay, where you have the one free phase. So if here was to be our free phase, okay, so you can count the holes, then you set the middle one. So 2, 4, 6, 8, 10, 12, 13. So you can say the seventh hole will be our middle hole, right? So 2, 4, 6. So this one we would have set our initiation point here. If here was to be our free phase. Okay. Do you get me? Are you following?
Yes.
So, but this one we have our free phase here. So even when you count it, it's either it will reach on this or that. So I will choose here as my initiation point. So initiation point, we use this one. Then lead in to click on it. Then if you click on it, this will pop up. I said for the initiation point, we give it zero delay. So zero delay. Okay. Then you click on that home. Okay. This, you see, it will set the initiation point there. Then from there, this will be our first hole. So here we are coming to use, for the surface connectors, we are coming to use 42 milliseconds surface connectors and 17 milliseconds. And also we use the 65 milliseconds surface connectors. So here what I mean is that we are saying this hole will go first, right? So the surface connectors are just wires. There are some wires that are used to connect the holes, to use it to link the hole, so that after, if you are using non-nail, that is non-electronic detonators. If you are using non-nail, that means if one hole goes, then the next hole will follow. But if you are using electronic detonators, it doesn't matter if one hole will go or not. The delays are already set, so they will just follow the sequence. So let's do it together. You will click on this one so that you can see the delays. Yesterday, I demonstrated on how to add a product. So if you want to add a product, just click on product. If you click on product, this will pop up. You choose the detonating code, then you can choose the delay that you want, or you can set your own delay, user defined delay. So you use this one, click on it to set your own, or mm, let's see. Okay, so for the user defined, you can use this one. Okay, click here, then use the product. When you click on the product, you see this one pop up. You can see user defined here. So when you check the user defined, you can set your own delay. Let's say you want to choose your own delay, like 34. Then, okay, so it will add your own delay here. Okay, so here I say we'll be using the 17 and 42. So for the 42, we use the 42 for inter-row, the inter-row delay. So these are our rows: 1, 2, 3, 4, 5. So these are the rows. So for the inter-row delay, we use 42. So this is how you go by the V. So first you link 3 holes like this. Then the next one you link two holes. Okay, that's the V type. Then you do the same. You start from where the other one ends. Then for as you continue, you go three three. So you start with three two, then you go three three. So there you go three three three. Then three here. But you see, when you start three two, you have to end with three two. Okay. So here we also go three. But you see the last row is only two because we started with three two, also end with three two. Then after setting your inter-row delays, you then tie up your interholes. So you have to tie up. So what we have done now is what we call the control. So these are the controls. These are the controls. Okay, something has happened there. Has happened something that we don't want to happen. This one, you see 34, 34. It's used the 34, this one, they use that define rather. So you can see 34 there, right? That's not what we wanted to use. We wanted to use 42. So let's delete. You can delete the delays. So these ones are just surface connectors, the wires that I'm talking about. So you can delete them. You check, you click on it. Make sure you don't delete the whole as you delete them. So you delete surface connectors. I wanted to use 42 millisecond surface connectors, but here 34 was used. So you delete them. You just let's click on it, then you press on delete on your keyboard. So let's use the 42 now. Okay. So three first, then two, then we go three, 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 three. Then you end it two because we started with three, two. Okay. Then for the inter whole, you use the 17. So you 17. Um, what happens is that we use a shorter delay from the initiation point. We use a shorter delay for one side, and we use a longer delay for the other side. The reason being that blasting, we know you want free phase. So if you set the delay for here and here to be the same, that means this row and that row will go together. We don't want that. We want some part to start breaking. Then it will set a free phase for the other side to break into. Okay, so here you can use 17 for this side. All right. Then you can use 17 for this one. So the control is like the control. These are the controls. What we did first is the control. These ones, the 42s are the controls. So what happens is that they will take the energy from the initiation points, then they will link it to the other holes. Okay. So you see here, this control will take the energy, then it will give it to this hole. The same applies for this side. This control here will take the energy, then it will give it to these holes. This will take then to give it to this hole. So you click, let's click on the hole you want it to start, then you let's click on where you want it to end. So it will arrange the surface connectors. Okay. This control will take the energy, then it will give it to the other holes. So just like that. So as easy like that. So you do the same for the other holes, 17. This control will give it to this one. This control will give it to this holes. This control will give it to the other holes, just like that. To give it to these holes. This will give it to these holes. If you don't do it properly, there will be a misfire. You get some of the holes not blasted. So you have to make sure you connect all the holes. Okay, you connect all the holes like this. So let me ask you, are we done? Do you think we are done? Or there is something that you have to do?
No, there's something we have to do.
What do you have to do? Yes, so we need a surface connector here so that it will give the energy to these holes. So here, let's
Yeah.
give it a longer delay. So let me leave 65 on it. So that the reason being that after the initiation point goes, so you see the timings are even there. So zero from zero, then this one will go, right? From here, this one will go. This one will go. Then from here, um, okay, we have 65 here. Oh, the same thing happened. Have you seen something? Think these ones are all 42s. They are supposed to be 17. So if you are choosing the delays, you have to check it well. We wanted to use 17, but let me show you the difference. Okay. So for the surface connectors, okay, for the 42, look at it here. See the symbol, just one line like this. But for the 17, there are two lines there. Okay, two lines crossing it. So if you see this, that means you are using 42. We have used 42 throughout, but that's not what we wanted, even though we said that, but I think when I was clicking on it. So if you finish using a particular surface connector, you have to right click close to before you choose the other one. Okay. But one thing about Shotplus is that this one, I don't have to delete them all again. You can choose to, so I will now choose 17 and reassign them. It will overwrite it. It will overwrite it. No, still. Let me see something. Okay. So let me choose the 17 again. Oh, what is happening? Okay. So you see the 25 worked, but the 17, let me see, 17, 17, yeah, didn't work. Okay. Didn't work. Okay. Okay, it's now worked. So you can see 17 here. So if you see any different number, that means I'm not using that particular delay. Okay. And see the symbol. There are two dash lines there. Can you see it? So that's the 17 because 17 has two dash lines. Okay, so you want to give 17 to these ones. 17 throughout. 17 will go the same for here. I'm going to give here 17 to 17 will go, then 17 will go here too. So if you want to scroll, just use the scroll wheel. Okay. The scroll wheel on your mouse. If you scroll, it will just zoom in and zoom out for you. Give you a 17, 17, just like that. Then finally, we give you a 65. Okay, I deleted a 65, so let me add it. 65. Okay, so then come, then give you a 65. All right, so that's it. So this is the tie-up for this particular party. So that means you can see the numbers there. So when the initiation point goes, 17 milliseconds later, this one will go. Okay. Then if this one goes, 59 milliseconds later, this one will go. The reason why we are seeing 59 is because for the control, we gave the interrow 42, 42. Do you remember? Remember we give here 42, 42, 42. Do you remember? Hello, do you remember?
Yes, sir.
Yes, so that means 17 plus 42 will
Yes,
give
sir.
you, okay. Then this here to 42 plus 59 will give you this. So that's how it works. It's just addition to set the timing. So let me delete this one. Then let's see how our blast outcome will look like. So now we are done. That's the tie-up for this party. This is the V tie-up. So can someone see Christmas tree here? Let's see how the shape for this one. Does it look like a Christmas tree?
Exactly.
Yes. So that's why they call it Christmas tree or the V when you have only one full face. So let's look at how the blast outcome will look like. So we come here, calculations, then you can visualize timing. So this is the pattern. So you can check here to show your tire. You can uncheck it to hide it. So let's see how the blast will go. So you just click on play. You see the holes are blasting. Then the shot will follow. That means this will go first, followed by this, that. You see how the blast will occur. So the
Yeah.
shot will help you to simulate and see how your blast will go before you even go and fire them, go and blast that. You can reduce the speed to make it slow so that you can see it. So let's play it again. We have reduced the speed to 1. So now it will go slow for us to see. This one will go first. So this is showing the energy transmission. Okay. So from this one will go, this one will go. Yes. This is how the energy will transfer. So after the energy is transferred, before the detonation will go on, let's see the blast. So this one will go first, followed by this. Then that's you see how the blast will occur. So that's it. And you can also, if assuming there is another, you will take for on that print, you will take another pattern here, and also you will take another pattern here. So you want to minimize cleanup because you know if you blast something, there will be a spillage. The fly rods and some of the materials here will spill all over. Okay, so if you want to minimize the spillage of material at the edges, you have to increase the delay. The delays at those edges. So if you increase the delay, the burden relief will be higher. Okay, so that means this if this one goes, it will take a while for this hose to go to blast. And this blasting, we want higher free face, you want more free face. So if this one goes and it takes a longer time for this one to go, that means this last hose will get a higher free phase, more free phase to break into. So it will minimize the spillage. Okay, do you get it? To minimize the spillage. So you can decide to use longer delays for this side. To minimize spillage. So after this hose goes, it will take a while for this one to go. So the last hose will get a higher free phase. So you can do the same here. You are increasing the delay for the last hose. Like this. So let's blast it and see calculations, then visualize time. So let's play it and see how the blast will go. You see, it will take, when this one goes, it will take a longer time before this one goes. That means you are giving them higher bending relief, so they will break nicely. So that's the blast. Okay. So you can also visualize the timing. So the same calculations, then you come to first movements. So this one will help you to visualize the timing and the movement of the blast. So you see the movement for this blast. That means because here is a free phase, and we want the material to break into a free phase. You see the movement. That means the tie-up that we did was very good because we want the movement to come here. We are moving the blast here. So if maybe assuming the same pattern, you do your tie-up and at the end, you realize that your direction is facing somewhere here. That means you have done something horrible. If you execute that particular blast, they will halt your operations of the mine. You have to make use of your free phase. So that's the movement of our blast. Any question for that before we end it? So that's it. That's the V tire. That's the V tire. Any question?
Sir,
Yeah.
if a particular hole is being delayed, won't it affect the other?
Won't it affect the other acid?
Yeah, because we have they've already put in the stemming material and other chemicals.
Mm.
Would it be a leakage?
No, the delays. You. I get you. You don't. The changes that I just made. You do all this on the software before you take the final plan to the field. You don't do it. Then you change the connectors there. No. To do everything, then you send this plan to the blast crew for them to execute it. Okay.